the final release will be available in a few short weeks from now. And that, really changes everything with respect, we're no longer, going around and telling people, oh, well, this is something we're working on, rather that this is real. And we've been working on this project for, well, in my case, 4 years. In the case, we really ramped up development, 3 years ago, which is a long time ago. So, it's a project we've been working on for a long time. I guess it's very difficult to come out here and stand up in front of people and explain to them why this is the best programming language ever, right? That's a really tough ask. And the best I can kind of really hope to do is give you guys a little bit of a taste of what some of the code looks like, and then maybe in the second half of this I ask for It's impossible to do these kind of things in a 45-minute slot. So I asked for this longer talk, so that then after showing a little bit of having a little bit of fun with doing some basic things, that maybe then we could get into a little bit of discussion about some of the things that to me personally I find interesting in Salon, in its type system and how we represent certain things, and that maybe almost feel a little too theoretical or too, airy-fairy, perhaps for you guys who are deciding, well, I want a language that, I can use to do, practical things, that I can use to do, real work in. And I don't want you to get the impression that, what this language is about airy-fairy type system stuff. It is, however, very important to us to have built an elegant language, because elegance is deeply correlated with expressiveness, with being able to abstract over things, with being able to, which means being able to reuse code and be able to develop, reusable generic machinery. So. Salon is a language for we call it a cross-platform language for a virtual machine. So it's cross-platform in the sense that the platform is a virtual machine. It's, as of today, it's the Java virtual machine or the JavaScript virtual machine. So the Salon compiler produces code, produces either Java bytecode in packaged module archives, or it produces JavaScript artifacts containing JavaScript code that conform to a somewhat popular module system in the JavaScript world called Common JS modules. Right? So I couldn't even start to talk about Salon more than 2 sentences without using the word module. So modularity is at the center of almost everything we're doing. The language is designed from the perspective of creation of modules. The tooling works with module artifacts. The compiler never produces .class files in a directory. It produces archives. The runtime always runs on a modular runtime based upon JBoss modules. So it's like having Maven and OSGI integrated into your language, your compiler, your IDE, your tooling, except that it's way simpler and more elegant than OSGI or Maven, which are both, I suppose because of the necessity of having to live in an extremely heterogeneous environment where everybody wants to do things their own way, are extremely complex and too flexible. Whereas if you integrate this kind of concepts into the language, then you're able to enforce a set of standards and an approach that dramatically simplifies the problem. And the value, of course, is that when you stick the job of Maven and the job of OSGI together, that's also a dramatically simplifying thing. So working with modules is dramatically easier in Salon than what you would have been used to in any other environment. Why is modularity so important? Because first of all, it's the only way to manage things that change. It's the only way to provide, to manage change in a way that doesn't horribly break compatibility. The lack of modularity in the Java platform has meant that Java has got stuck with legacy APIs that have not moved with the times. Secondly, because a lot of the deployment environments we're considering, these days in the cloud or on mobile devices, a monolithic, a monolithic SDK of the nature of the SE platform, the EE platform, just don't cut it. It's just not the right approach. And thirdly, and perhaps most importantly, we come back to this notion of cross-platform. For cross-platform execution, we need, to really realize this notion of being a cross-platform language, we need a very, very small, minimal language module that works exactly the same on a JavaScript VM as on a Java VM, or exactly the same is slightly overselling the case. There are some fundamental difference in semantics between, for example, numeric types, but in principle is the same on both platforms, and then the ability to build cross-platform modules in the language, which have dependencies only to that core minimal language module and to the definition of the language itself, so that you can write code which executes across both platforms. Obviously, we also need the ability to find modules which are not cross-platform, which are specific to the services that are available only in a Java virtual machine. So we also have, interoperability with Java, with the Java SDK, with other Java libraries and frameworks. But you always know when you're doing something that's not cross-platform, right? It's well defined. If I import the module Java base, then I know I'm using the Java SDK, and my code isn't going to run on a JavaScript VM. All right, so let's just to vaguely demonstrate that this stuff works on on both VMs. Let's create a very, 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 very simple little program to get started. So this is the oops, how did I miss a quote? This is the Hello World program in Salon, and we can run it as a Java module on the module runtime. You can think of this as a module runtime. You can think of it as a container, somewhat similar to an OSGI container or something like that. It's JBoss modules. It's the core of JBoss. It's the very minimal core of JBoss application server. Extremely minimal, which is integrated into language in the runtime. Or we can run it on Node.js using CommonJS module. So I just, that looked extremely unimpressive, but I just run this program on two different virtual machines, highly dissimilar virtual machines. All right, so you can see what a function looks like in this language. Much the same as a function in C, really. So this, the only difference is that instead of a keyword public to make the thing visible outside the module to which it belongs, there's an annotation called shared. That annotation is defined in the Salon language module here. There's a function called print, also defined in the Salon language module, which we're calling. After functions, the next most important thing you encounter in a language is a value. So here, that's what it looks like to have a value. We can use the value modifier, which just means infer the type of the value. In this case, string. I'm allowed to take this and stick it out here as a top level declaration, and my program's going to work the same. So, you know, there's a bit of kind of baggage come along from the OO world that, you know, that it's bad to have things in the top level and that we should make these static methods and values that we kind of wrap up in this fake class that we don't actually ever instantiate. And that's basically just, I mean, it's witchcraft. It's not actually based in anything. These are not globals in the sense of evil, you know, globals in the sense of pre-modern programming languages, because they belong to a namespace, right? So the package itself is a namespace. There's no need to wrap them in another namespace in a class that we never instantiate. That's you know, essentially just rubbish. You might notice I have an error here. The error is because Salon supports local type inference. It does not support type inference for top-level declarations. There are very good reasons for this, and in terms of being a massively simplifying assumption, in terms of making your, you know, the whole type inference system decidable, and also in terms of that, you know, top-level declarations are generally the ones which are visible, you know, outside the compilation unit I'm working in, and documenting the type of things is actually just simply a good thing and a useful thing for the programmer. So we think that non-local type inference is very nice. Unrestricted, you know, that local type inference is very nice. Non-local type inference is in fact harmful. Okay, so well, this is, you know, not a very interesting program. So let's go and start demonstrating some, you know, using some modules which will let us do some slightly more sophisticated things. This time around, I'm going to create a project which is compiled just for the Java virtual machine. So, I don't know, call it something stupid again. Oh, I forgot to add the... So we're going to need some dependencies. Yeah. I'm going to create a module. The module name will be something stupid again. And I'm going to need to use some of the Salon platform modules, which are you know, part of the Salon SDK. I happen to have these already on my machine, but if I did not have them on my machine, this would have gone and queried all the way to Salon Herd, which is our community module repository. You can see over here. No, it's over here. Modulesalonlang.org. You can go and browse. You know, all the modules we have available, and their you know, and their documentation. And this is a module repository where, and the tooling, you know, knows about this one, and it will find modules there if they're not already available on your machine. So I'm going to use, what am I going to use? SalonNet, which, as you can see, is a module which contains a HTTP client and a HTTP server, among other things. And I'm going to use Salon HTML, which is a simple, this is still under development, but it's a simple library for letting you construct HTML within the programming language. So that's my module and its dependencies. So let's finish up here, and I get a file. Let me look what else I got here. I got a module descriptor, and here's where those dependencies of the module are expressed. So this is all expressed in code. It says what module I'm using, what its version is. And also I got a package descriptor, less useful, but what the function of this guy is to say that this is a shared package, and so that it's visible outside the module it's defined in. So I'm going to create a HTTP server. that code creates a HTTP server and starts it. Obviously, that's not very useful. We're going to need some kind of endpoint. Create an endpoint. The path is going to be we're going to listen on any paths that start with a slash. It's nothing. Yeah, that's stupid. That should have happened automatically. And oops, wrong one. There we go. And so we have let me make this bigger. So what am I looking at here? I'm looking at a function invocation. So this create server here is a top level function that is accepting I think it's an iterable of endpoints. So endpoint is a class here which has an argument named path, right? That's here, and an argument named service, which is declared here, which is a function. Here, within this named argument list, I'm defining the function service, okay, using a normal, C-style function declaration. So if you like, you can think of this is not really how I think of it. If you like, you can think of this as something like passing an anonymous function. You can think of it as being this service equals void, right? This means essentially, it means the same thing as that. Right. So we're passing a function to a function, to a constructor. Constructor is a function in Salon. So I got a response here, so I can write some stuff on it. And let's run this, see if I did anything wrong. Okay, HTTP started. It's on port 8080, that's the default. And yeah, there we go. All right, so what's that? All right, that's just a stupid string I wrote directly to the browser. So let's create some HTML. So you recall that I imported this module, which is a Salon HTML, which is for defining, like it itself says. This module allows you to write HTML templates in Salon. So we're going to need a doc type, which is going to be HTML5. We're going to need a head. With a title. The title. And we're going to need a body. And in the body, I'll add a P tag, a paragraph, with down here, I'm going to convert that tree of HTML tags to a string. So you can see that these are just classes. So these classes written in Salon are expressing the schema of HTML. So because it's a type-safe language, because this is not a dynamic language, we get tooling support. Okay, the compiler will tell us when we've written something that's not legal HTML. Or we can get, auto-completion, which will tell it, if I type that, then I get an error, and I can auto-complete it back to title, right? So it's a schema. So it's a language with a schema with tooling support. Now let's run this thing again. Oh, I probably need to stop it first. Did that do the right thing? There we go. Now if I reload the page, it looks slightly different, but if I look at the source, then I have some, nicely formatted HTML coming out the end of it. All right, so let's go back and start to do something a bit more interesting here. While we have a request here, let's try and make use of some stuff that's in the request. So I'll turn this attribute, value, into a function. So this is a function definition. The fat arrow, as in some other modern languages, means it's a function that just evaluates and returns the evaluated value of an expression. And this is extremely common. In a language like Salon, you have a lot of very, very small functions and very, very small methods. You don't tend to get these great, long, multi-hundred line methods or functions in Salon. It just doesn't happen as much because the language is different to say Java or something like that. So it's very common to have functions that return an expression. Did you have a question? Yes.
And I'm wondering what's the benefit from this solution, because for me it's kind of ideal world that will never work in real. I mean, I know lots of stuff.
It worked.
Yeah, I know, but I know lots of stuff that you change the HTML depending on the browser, because some browsers support some stuff, some not. And kind of standardized way of doing.
It's just
things.
Code, right? If you need to change something in the browser, you just write an expression that changes the thing you need to change.
Yeah, but you are still limited on the class model and what's in the API, right?
But the limits were. The concept. It's not finished yet, obviously. But the concept is that the limits that exist there in the classes are the limits defined by the HTML spec. Right? It's the same set of limits.
Yeah, but what I'm trying to say is that not every browser supports all HTML5 stuff. Right?
Well, sure.
Or support it in a very different way. So.
Sure, there are challenges that you can, take and find solutions for. But fundamentally, at the end of the day, it's just code, right? You can do anything with code. In fact, you can do a lot more with code than you can with XML. It's much easier to customize and change code. At the end of the day, a string comes out of this. If you need to work with it as a string, you write some code to work with it as a string, right? To change the resulting string. It's easy. It's all there in a programming language. Programming languages can do anything. It's all right. I need to pass the request in there. I'm going to use the string interpolation syntax here to say request dot parameter conference. All right. So we can see that what I've created here is starting to look like a template in a templating language, right? Even though this is a programming language, what I have here is something that looks like a template in a templating language, right? I'm starting to do interpolation of values and all this kind of stuff. So why is there an error here? This should have worked, right? So this will give us a chance to explore something interesting. So it says interpolated expression must not be an optional type. String question mark is not assignable object. What the hell does that mean? Well, let's pull this out so we can explore it a little bit further. I'm going to change this to a block temporarily so I can pull this out. Conf. Oops, this is all messed up. All right, so let's look at the type of this guy. His type is string question mark. I'm going to tell you what that means. What this means in Salon is this, null or string. String question mark is syntax sugar. Salon is a language with a whole lot of syntax sugar over a very simple type system. This is a union type, what you're looking at here. What this bar syntax in a type declaration means is that conf here can be either a string or a null, whatever that is. So let's go and have a look at what null is. Null is a class written in Salon, abstract class with just one instance. Let's have a look at what it says about itself. Null is the type of the null value. Any union type of form null or T is considered an optional type whose values include null. Any type of this form may be written like that as T question mark for convenience. You see that null has a supertype called anything. It says the abstract supertype of all types. An object is a supertype of that. Now what it says is that anything is an enumerated type of object or null. What this declaration says is that anything has only two subtypes, direct subtypes, excuse me, that they are disjoint, okay? So any, and it says it's the abstract supertype of all types, every single value in the language is an instance of this class, right? If we go and look at what its subtypes are, here you can see the whole universe of Salon here. But right at the top level, we have null and object. Everything is either an instance of null, which we just saw has exactly one instance, this object null, or an instance of object. Most importantly, this object null is not an instance of the class named object, right? So if we have something that says it requires an object, i.e. a well-defined value, I can't assign something that might be null to it. So how am I going to do with this here? Well, one thing I could do is use an assertion that says is object conf. And then my error goes away. Why it go away? Well, now conf has type string. So this assertion that conf is an object narrowed the type of this value to string. How did that work exactly? Well, let's just see something silly that was meant to say, but I can't type and I can't be bothered fixing it. Interface I, interface J, say I've got a, well, let's pull them out of here and put them here, and let's say I get an I as a parameter here, and then I say if is I, if is Ji, what type do you guys think obj is going to have? What type do you think that what I'm asking is, what type do you think this guy has inside this if statement? J. Good answer. Not the answer I'm looking for. Let's get the IDE to tell us. I and J. This is an intersection type. Right? We already knew it was I. Now we know it's J as well. So within the block, we know that it's both I and J. Right? So up here, where we started out with a null or string, and then we asserted that it was object, what actually happened was that the compiler formed the intersection of null or string and object. It applied the distributive rule from mathematics of sets to turn that into null and object or string and object. We know that null and object are disjoint types from the definition of anything that we just looked at. So we know that that type null and object is the empty set, the empty type. There's a type called nothing, which is that. Or string is a subtype of object. So we know that string and object is just string. And we know that the union of nothing and anything, the union of empty set with anything else is just the anything else. And so what popped out at the end for the type of conf was string. It's exactly the reasoning the compiler does in all that. It does it, a lot better than we can do it, but we can actually easily reproduce that kind of reasoning because people are very, sets are very intuitive constructs and it's very easy to think about sets. We usually in Salon, instead of writing is object all over the place when we have to deal with a null, we write exists. And that's just another syntax sugar over the top, which just means precisely is object. Okay. In fact, in this case, this is not what I really want to do. I want to deal with the null in a different way. I want to use the else operator. And and provide a default value when parameter returns null. And now, what do we go? How are we going down here with the? Okay, that still says that now. So let's try conf equals. Krakow. I don't need quotes. What am I doing? Done something wrong here. No, I do not. There we go. There we go. Oh, so that's a little introduction to how we handle null values. To continue on this theme of, I'm going to inline this. Change this block back to this. To continue on the theme of, of making this look more and more like a template to convince you guys who are very skeptical that I can really do the things I would do in a templating language, let's, display today's date. So, I can get today's date. That's not the one I'm looking for. Oh. I need to add a new module to our project, a new dependency to our module, which is Salon time. know if that's pulling that off the internet or what. It's embarrassing, though. Yeah, have an internet connection. Has Eclipse crashed? It stopped, hasn't it? All right. All right, where were we at? Now it's left with a mess, huh? Yeah. Should be good now. Day. And so you can see how this is looking, more and more like a templating language. So we're using here Salon's, really nice date time module, which is not written by me, so I'm not talking up my own work. Written by some contributor, two guys who took Joda time as a motivating model and built a nice date time library in pure Salon around that. So now there's a really nice date time library which will run in JavaScript as well. All right. What do I want to do next? Here we go for time. I have an hour. Okay. Should we change pace a bit and talk about something more type system-y? What do you guys think? Yes? All right. Okay.
Maybe more about use cases. What do you think? Special use cases.
I'd rather talk about type system. Yes.
Is it possible to mix marks from different namespaces in this way of making HTML?
Mix tags from different namespaces?
Yes. In one document.
In principle, I mean, our HTML library doesn't support that. I mean, certainly not at the moment. It could probably, but no, there's no, in this HTML library, there's no support for anything like XML namespaces. Presumably, such a thing could be engineered into a similar library. For example, if we build something like this for XML, we would need to. It's not a problem I've put any thought into, but I assume that there shouldn't be any problem with doing that. But the HTML library doesn't support that. And the HTML world's kind of moved away from that sort of thing. So moved away from XML, I should say. So let's, in order to demonstrate, I want to start touching more on some other ways in which union types are very nice. I want to demonstrate a problem that, I'm not sure if you've run into in Java. Probably you have. As a way of getting starting to get a hook on this concept of covariance, I sort of often start to try and in a talk trying to talk about covariance, assuming that everybody knows kind of what it is, and because they've used it in Java a little bit, and they might know it from other languages, and it turns out that's often not true. So for those in the audience who do know what it is, I apologize for, and to those who don't, I want to say this is really useful stuff to get your head around, because all modern statically typed languages have, this problem occurs in all of them, and they have differing solutions. So let's talk about arrays in Java. So say create a array of strings. So I'm allowed to write that in a... Yeah, I am. Okay, but I'm going to need a method here. So let me take my array of strings. It's an extremely intuitive thing to almost everybody to think that if I have an array of strings, then I also have an array of objects, because a string is an object. It's a deeply intuitive notion that what I'm about to write is something that should work. Most people intuitively expect this to be something that they can write and something that should be correct. So let's do that, and then I've got an array of objects here, so I'm going to set this to object, and I'm going to run this. This is all well typed, right? The compiler didn't bitch at me. Public static void main string args. I could have just done it with the arg string. Hey, static. And I get an array store exception. What's this? This is a typing exception, in fact. It's a runtime type exception. So this is a hole in Java's type system, where Java's type system is unsound. Java let us write something which failed at runtime with a typing exception. In fact, it's not sound to go sticking an object in an object array, because under the covers, an object array might actually be some other kind of array that an object can't, that a plain object can't live in. So in fact, with Java generics, you know, they realized that that was a bit of a problem. So so in Java generics, you get a completely different behavior. If I have a list of object, then in Java generics, I can't do that. What we say the difference between these types is that arrays in Java are covariant. Generic types like list are invariant. We can form a covariant type from an invariant type in Java using a wildcard. Right? Now, the way the Java generics works with wildcards and all that is all perfectly sound and perfectly good, but it results in the most atrocious, awful typing exceptions you've ever seen. Errors which with question mark capture of blah blah blah, because wildcard capture is this amazingly complex and thing that, you know, I mean, you can sort of understand, but you can't really understand it, and nobody understands it, and people avoid using these constructs, covariant and contravariant generics in Java because it's just so horrible. It's also extremely verbose. You don't want to be writing a whole lot of code which pass around list of question mark extends object just because it's too much typing, and Java makes you type that out explicitly. So Salon uses a different model, and which I'll show you by showing you. Well, no, let's make a class and we'll see how it works. Let's go back here. Make a class called list, called myList. And this will be generic, so it'll have an element type, and it'll have an add method, and it'll have a it'll have a get method. Oh, I don't have to do that one we're talking about. And if I want to take this and and assign this to a then, again, like Java, that's not well typed. Right? This is exactly the same code that we just saw in Java, which you all know. So this is not well typed. Now, unlike Java, I can't go starting writing extends, Salon has a different model. Java has a model called use site covariance. Salon has a model called declaration site covariance. If I want to make this work, I have to go up here and stick an annotation on the type parameter. Then it's well typed. But you notice something? The add method has an error now. Okay, so I have to remove that operation there. And now I have what is a legitimate covariant type. And I can't go starting adding objects to this list of strings because It's a covariant type, and it wasn't allowed to have an add method. I can create a subtype of my list, which is invariant and has an add method, and so that's generally what you see in Salon. We have a list interface and a subtype, which is a mutable list interface. Right? Now, where and this is not unique to Salon. Declaration site variance is something that comes from, I believe, originally from OCaml. But where Salon really makes it work out nicely is that Salon has union types. So I can write something like this. Let me grab another module which has linked list in it. Oops. Salon collection. So, you notice how different this is to Java. I could create a list without specifying the element type anywhere. Okay, not in the instantiation and not in the declaration of the attribute. And it infers a correct type, linked list of string. Okay, great. This is something which has traditionally caused a lot of problems for programming languages which combine subtype polymorphism, i.e. object orientation, okay, so subtypes, with parametric polymorphism, generics. Right? So this combination of subtype polymorphism and parametric polymorphism is incredibly powerful, but combining the two together is an ongoing problem for programming languages, and existing programming languages do it imperfectly. And I hope that, we've now come to something where it works better. So for example, this is a problem for most languages. And this kind of thing is the reason why, for example, Java will force you to write an explicit type somewhere. What's the type of list there? Somebody tell me. See if you've been paying attention. What is it? Tell me. A list of integer or string, right? Yeah, exactly. So the type there is linked list of integer or string. Okay? So that's actually very intuitive and very simple. We can now model correctly the type of a heterogeneous collection of values without problems, without needing to write down any types, any type annotations or anything like that. And you might think that, well, I don't want a freaking list of integer or string. I want a list of object or something or anything or summable or some other common supertype they have. So this is wrong. I don't want to write integer or string everywhere. And now we come back to why covariance was so important, right? Because this guy, this guy is a list of objects. Because list is a covariant type, and integer or string is a subtype of object. Because integer and string both have object as common supertypes, as a supertype in common. Indeed, any common supertype of integer and string is also a supertype of integer or string. Okay? And that is a key thing which makes the whole system of type inference work so nicely. If we start to get up to some other more complex cases involving invariants and stuff like that, intersections also start poking their head into this question of type inference. Right? So these interlocking concepts of variants, intersection types, union types, start to solve problems that previously were not solvable in a satisfying way in other languages. And notice that if you get this wrong, I don't know, what's another type? Float. You get a meaningful error. And this is a critical thing in Salon, all right? The Salon compiler uses the same notions to reason about the code that you guys do, right? There are no non-denotable types in Salon, right? Because things like unions and intersections are denotable, expressible within the language itself, the compiler doesn't need to have its own private special types, which it has internally, but which it can't display to the user properly when it goes to type checking the code, right? The error messages that come out are sensible ones that tell you precisely what the problem is, because we can express the types which are incompatible within the language itself. Yes?
If you would make it back to object, and you would pass in a null value in the list, would there be anything
Okay.
in an object?
Yeah.
Sorry.
Let's do it. I don't like to tell you. I like to program it, right? Not assignable. Linked list of null or integer of a string is not a list of object. So what is it? Well, it's definitely that, right? It's a list of object or null. It's also an anything, because anything is a supertype, which is what you said. Exactly. So it all works out, right? You know, at this point you guys are going, oh yeah, maybe there's something to this after all, right? You know, it just all works out intuitively and naturally. All right. Time. There you go, a little bit more time. So let's start to explore a different area which languages have had problems with, and that's, you know, the question of integrating function types. You know, I mean, function, you know, higher order functions and you know, functions as values has been around since the very earliest programming languages. You know, Lisp and Scheme have it, Smalltalk has it. Smalltalk's not one of the earliest programming languages, but the notion of being able to pass a reference to a function is a very ancient and storied feature of very many languages, and all modern languages support it now. However, it has been problematic for languages with static typing to express the type of a function. So, for example, in Java 8, which is, you know, which otherwise their approach to function. I mean, I think what they've done is good, and don't take this as criticism. In Java 8, there are no function types. There is automatic conversion of a reference to a function into a single method interface type, right? Which means that you have to have predefined these single method interfaces. And so what they've done is it's very reasonable. They've gone and predefined a whole bunch of reasonable ones that people are likely to want to use, and then all the collection framework and all that reuse those, and other people's code will reuse those, and that all makes lots of sense as far as it goes. What it means, however, is that you can't abstract over function types. You can't even abstract over function types in Scala. I don't know Scala very well, so perhaps I'm talking a little bit beyond my area of expertise. But in Scala, there are F1, F2, up to the arbitrary upper limit of F24 or something, beyond which are monsters. And I can't have a function or a tuple of length 25 for some dumb reason. I think this is going away, by the way. Well, it might be going away, but I mean, it should have gone away a long time ago because it's rubbish. so it has been problematic in statically typed languages to have a a type that abstracts over functions. Other languages have defined function types primitively, and then maybe you can do more abstraction over them. But so when we came to this problem, we didn't want to do something like that. We wanted to be able to abstract over function types and write higher order functions which can for example, compose together a function which accepts a string and a function which produces a string and accepts integer and a float, right? That's something which is difficult because the compose function, right, has to be able to abstract over functions of different length parameter lists, right? I'll show you something more concrete in a second, okay? But I want to get to the basic idea. The basic idea is to go back to mathematics, which we learned in high school. And what does anybody here know what the definition of how mathematicians go about when you're doing constructive mathematics, right? How mathematicians would go about defining a function with multiple parameters. What is it? How do you define that? Maybe we don't have I'm a mathematician, so for me it's so a function with multiple parameters in mathematics is defined as a function that accepts a tuple, returns a value. Okay, so a function is obviously a set of ordered pairs. A function with multiple parameters is a set of ordered pairs of a tuple and a value. Right? So constructive mathematics definition of it. So we took that. So we took that notion. So a function type in Salon. So if we have, I don't know, what's a function? Let's make a silly function here. Plus. So if I assign a reference to this function to a value, what's the type of this guy? Well, it's going to present it to you with a syntax sugar. This is a syntax sugar that says the type is float, comma float. That's just a syntax sugar. What that means is callable of. Why didn't I propose that to them? What that means is that this is an interface, ordinary interface expressed in the language. This is a tuple type. Okay, so exactly the definition from mathematics is exactly the way a function type is expressed in Salon. So now we come of how do we express a tuple? How do we express a tuple type? Well, that is also just a syntax sugar. Let's see if I get this right. We, of course, never write this type out explicitly. We always use a syntax sugar when talking about tuples. We have a class, tuple, written in Salon, compiled with the Salon compiler. So it also has some optimizations going on under the covers, but called tuple, which has a recursive definition. Okay, so what it is it's a linked list. Okay, but it's a typed linked list. Each link in the chain carries along with it the type of that element of that link in the chain. So if normally I would construct a tuple like this, 1.0 and I get something that is an integer string float, right? That's how I usually construct it. But if I want to, I can write it like this. Integer, what did I have? Tuple. And then empty here. And that means the same thing. Under the covers, we optimize all this down to a Java array for the record. Just like null, this object null gets optimized under the covers down to a virtual machine level null. Okay, so don't worry about the performance impact of this stuff because we do lots of magic. So as you can see, we've expressed the type of this function completely within the language, completely within the language's type system. Right? What that means is that we can abstract over it. So I can write. So coincidentally, yesterday on the mailing list, somebody asked me a question of. Let me first show one interesting thing. Okay. So there is a deep equivalence in the way the language thinks about functions and tuples, about function argument lists and tuples. Therefore, okay. So a function. The type of an argument list is a tuple type, right? Let's get rid of this rubbish and just, and go back to what we always write. Okay, and let's make this a tuple of floats. Okay, so I have here. Let's get rid of this rubbish here, which we don't care about anymore. I have here a tuple of two floats and a function plus, which accepts a float and a float. And one of the things I can do, therefore, is pass the tuple to the function. So the spread operator, so I'm not sure if you guys have used Groovy or a language which has this syntax. So, stupid hover. So what this syntax does is it says, take a list of values, a sequence of values, and map them across the parameters of the function. It's pretty cool and it's quite useful. Now, in a statically typed language, that's a little bit more problematic. We just can't just map a list of, an arbitrary list of strings and integers across a function which accepts one string and one integer in a type-safe way, right? In Salon, on the other hand, because we have, tuple types and this correspondence between tuple types and function types, that is something which the type checker can check. I mean, if I try to, do something wrong here, then it'll complain, right? Or, if I try to, pass an extra parameter there, then it says that, the spread argument is not assignable to the parameter types. That's not assignable there. So this guy was saying, well, that's pretty cool how you can do this, because what he wanted to do, he had a function where he wanted to use a tuple to return multiple values. So he wanted to return x plus. So he has a function like this which returns multiple values. And he's like, and then I have another function here, void print, which takes a, it's called something else, print string float. And which does something with that, right? And he's like, so it's nice that I can, that I can do, this. I want to take print string float, the output of plus, and then a couple of values. Well, spread our tuple across there, why not? He's like, that's pretty nice. But what if I want to compose those two functions together? Okay, because this function plus produces something that's assignable to the inputs of print string float. So he's like, I want to compose those two functions together. Say I don't know what tuple is yet, and I want to compose those together. Sure, I can write a function that does it, right? But I want to use Salon's compose function to do it. Right? So I want to write print string float plus and then pass some arguments into it, and then pass some arguments. So I want to make this this is going to be some new function, right? And he's like, well, that doesn't work because this accepts multiple parameters, and this just produces a single value. And if we look at the definition of compose, well, I mean, it's assuming a function. And I'm like, well, there's another function there called unflatten. Is it flatten or unflatten I'm looking for? Unflatten. Which takes a function with multiple parameters and produces a function which accepts a tuple. And so then I can use compose to compose together these two functions. This is not possible in other languages, right? This is only possible because we've expressed function types within our type system using this recursive type tuple, and so we can create these generic higher order functions like compose and unflatten, which abstract over functions with different length parameter types and stuff like that. And so I think that's pretty cool. Of course, it's not the thing we're doing all the time in Salon, but it's a nice thing, and it shows some of the advantages of elegance in the design of a language, right? Elegance being expressing everything in terms of simpler constructs, right? So tuple is a class, and from that we've layered over it the notion of tuples, the notion of function types, and all that kind of stuff. All right. So do I have more time? Do you guys want to ask some questions for a little bit, and then any questions at this point? Yeah. The ultimate goal of Salon is to make programming nicer. I mean, nothing more than that. So it's an alternative Java, but it's more than that, because I mean, the cross-platform nature of it makes it a bit more than that. We want you to be able to write, the write once run anywhere promise of Java is a really nice promise, but unfortunately, because of the way history went, it's not really right, because I can't write a web client, which is one of the most important things in the whole technology world in Java today. So this abstraction of the virtual machine is very important. The ability to be able to serialize an object from a JavaScript client to a JVM backend and send information back and forward and work with it in the programming language itself.
Okay, assuming that I would like to play with the language, of course I do. It's really good, look nice. But could you help me convince someone who's in charge that I can do so during their working hours, for instance?
I mean, that's always the big challenge for a new language, right? I mean, because it's it's not just a new language; it's a whole new platform, I mean, you always have when you're trying to develop any ecosystem from scratch, you always have the problem of it's useless to anybody until somebody starts using it. fortunately, you know, Salon is something you can adopt incrementally. Our interoperation with Java and the Java SDK is, you know, I think it's reasonably characterized as excellent. There are other languages which interoperate more smoothly. The cost of that is that they're more tied to Java than Salon is. Again, the two big selling features in terms of people, in terms of people asking, well, why should I use this? The two big selling features of what capabilities this has that, apart from just making programming nicer, are, the cross-platform nature, the fact of, which is, potentially very game-changing. There is currently today no good language, no language which has a great story, in my view, for both client and server. And that's not to say that Salon has the best story for client of any language, or but you can at least send your objects over there and use them over there on the client. That's potentially something which nobody else offers. This story we have for modularity is something that nobody else even remotely offers. And modularity is absolutely core to everything we do. Modularity is the whole goal of software engineering. And the fact that programming languages have not traditionally had modules as a first-class construct is confusing. It's curious. Yes.
A little bit more about modularity, about versioning, and
right. I mean, yeah. So the question is, can I talk a little bit more about modularity and versioning? Honestly, our module system is very simple, partly because at this point we don't need anything enormously complicated, right? It will obviously over time grow features, but we want to see it grow features in a controlled way that features people actually need. For example, there's been quite a lot of discussion about should it have semantic versioning, so you can have version ranges and stuff like that. I argue that no, because in a very soon future version of Salon, we'll grow the notion of assemblies, right? So an assembly will be a descriptor where you say I have an application or a service which is composed of this version of this module and this version of this module and this version of this module, and that overrides the version dependencies which are specified by the modules themselves. Okay, so currently the dependency system is super simple. A module specifies what module and what version it depends upon. This is good because essentially version ranges are lying to you, right? When a module says I support 1.x, 1.*, right? It's lying to you. It has no way of knowing whether it really works with one dot.
I don't completely agree. If you do semantic versioning correctly, then actually
But it's a big if. It's a big if. Sure. If you do semantic versioning correctly, then yes. But you can't test your module against future versions of its dependencies, right? So I don't love version ranges. Doesn't mean we won't grow them eventually if people say they have to have them. I prefer the notion of an assembly, which is, from my way of thinking, non-lying. Okay, it says, I have tested these modules together and they actually work, right? So it gives you it gives you a way to override what this module, the out-of-date information that this module might have in its descriptor, and say, no, even though the module says it requires this, I've tested it, it actually works against this other one, right? And assemblies, assemblies also. Currently Salon lacks a notion of a service or an application, or the notion of being able to deploy multiple services applications into a single virtual machine. This is the kind of capability an application server offers you, right? Salon doesn't have this capability today, but I work for JBoss, so
I kind of understand the choice to go for a simple module system because, well, otherwise it just gets more complicated. But let's say I'm in an OCI environment and I do want to use Ceylon and I want to produce metadata for OCI bundles.
Yeah, so one thing that we're almost certainly going to do, it's not going to be in 1.0.0, but we're certainly going to do very soon because it only just occurred to us. we can easily from our modular descriptor generate OSGI metadata
most
as
of
in
the
the meta
metadata
if, and then our Salon module would be an OSGI module. I mean, maybe there's some extra complexities to that which haven't occurred to us, but I mean, when we thought about it, we're like, well, what's an OSGI module? It's just a jar with
do you also version packages?
the manifest, right?
Do you also version packages? If you export or share a package?
Yeah, but we have that. No, we have that. We have that metadata. Which of our packages are shared, right? So that's already there in the. You saw the package descriptor, right?
But do you also version them?
Our packages aren't independently versioned. No.
Okay, that's probably the only metadata you're missing then to go for truly OSGI metadata.
Yeah, but I mean.
But that should be easy to add.
I mean, it should be really easy to produce that OSGI metadata. Just have it something that the compiler just does, because it's not heavyweight, the OSGI metadata. It's really simple, and then you should be able to just deploy a Salon module in an OSGI container. I don't see any reason why not. Why this came up was that we were thinking about, well, actually, we would really like to start writing some bits of the IDE in Salon, not in in Eclipse and OSGI. So we're also working on Maven interop as well at the same time, and that's not completely there and working. We have a big problem because Maven repositories don't really, all their metadata is broken. They don't specify all their dependencies because they're used to the concept that Maven runs on a flat class path, and so they don't explicitly specify everything they depend upon. And so what do we do because we don't have flat class paths, and it's really problematic, but we'll figure out something. Something will be something like everything that came from Maven runs on one class loader, right, or something like that.
It's horrible. I've been there, and it's painful.
Talk to me about Maven. Any other questions? No? All right. Thanks for coming, everybody. I appreciate it again. And I hope
Thank you very much for your lecture.